Welcome to Exquisite. In the previous classes, we learned about the electromagnetic spectrum. In this class, we will learn more about the spectrum.
Yes, I can now make the electromagnetic spectrum.
Please go ahead.
The electromagnetic spectrum consists of the 7 electromagnetic waves.
Okay.
Starting from the one that has the lowest frequency, to the one that has the highest frequency. The waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray.
Good. Let's now talk about the waves, in terms of their wavelength.
Okay.
Do you remember the relationship between the wavelength and frequency of a wave?
Yes, I remember that V is equal to F lambda, where V is velocity or speed of the wave, F is the wave frequency, and lambda is the wavelength.
Great. Something interesting I like to let you know is, all electromagnetic waves travel with the same speed in empty space. And the value of this speed is about 3 times 10 raised to power 8 meters per second.
Wow! Sensei, I know that value as the speed of light.
Yes, TD, you are right. It is the speed of light, but it's also the speed of all other electromagnetic waves, whether light, radio, microwave, X-ray, gamma ray, and so on.
Oh, I get it. All electromagnetic waves have the same speed in vacuum or empty space.
Correct. So, we can use C in place of E, in that formula, and it becomes C equals F lambda.
Okay.
Now, if we make F subject of the formula, we get F equals C over lambda. Since C is constant for all electromagnetic waves, the formula clearly shows that F and lambda are inversely related.
What does that mean, Sensei?
It means that, if F increases, then lambda will decrease. So, electromagnetic waves that have high values of frequency, will have low values of wavelength.
Okay. I see. High frequency means low wavelength.
That's an excellent way to summarize it. So in our electromagnetic spectrum, frequency increases in this direction, while wavelength increases in the opposite direction.
I get it. Gamma rays have the highest frequencies, and so they have the shortest wavelengths.
Correct.
While radio waves have the lowest frequencies, and so they have the longest wavelengths.
That's very true. Now, how long do you think that radio wavelengths are?
I don't know.
Okay, I will give you an idea. Radio wavelengths are usually longer than 10 centimeters. 10 centimeters is the same as 10 raised to power minus 1 meters.
Okay, how about visible light wavelengths?
They are usually between 0.4 and 0.7 micrometers. That is somewhere there, just a little below 1 micrometer. 1 micrometer is the same as 10 raised to power minus 6 meters.
Oh, I see. A very small portion of the electromagnetic spectrum.
Yes, the visible light represents a very little portion of the electromagnetic spectrum. It is the only portion of the spectrum that can be detected by our human eye.
Okay, how about the frequencies?
To get the frequencies, all you need to do is, simply put the wavelength in that formula. The speed of light in meters per second, divided by the wavelength in meters, will always give the frequency of the wave in hertz. For example, radio wave of 1 meter wavelength, will have a frequency of 3 times 10 raised to power 8 hertz. That value is obtained by dividing the speed of light, which is 3 times 10 to power 8 meters per second, by the wavelength, which is 1 meter. And that gives 3 times 10 to power 8 hertz, which is also the same as 300 megahertz.
I get it. So if a radio station says, they are broadcasting at 300 megahertz, it means that the wavelength of their radio wave is 1 meter.
That's correct. So, can you now tell me the frequency of visible light that has wavelength of half micrometer?
Yes, half micrometer is the same as 0.5 times 10 to power minus 6 meters. So the frequency is the speed of light, which is 3 times 10 to power 8 meters per second, divided by the wavelength, which is 0.5 times 10 to power minus 6 meters, and that gives 6 times 10 raised to power 14 Hz. Somewhere there in the electromagnetic spectrum.
Perfect, TD, and that brings us to the end of this class. Before we go, give us a summary of the things you learned.
Okay. 1. All electromagnetic waves travel at the same speed through vacuum. That is, 3 times 10 raised to power 8 meters per second. 2. The frequency of an electromagnetic wave is connected to its wavelength by the formula, F equals c over lambda. Therefore, 3. The frequencies of electromagnetic waves are inversely proportional to their wavelengths. Radio waves have the lowest frequencies but the longest wavelengths, while gamma rays have the highest frequencies but the shortest wavelengths.
Great. In the next class, we will be learning about the sources and uses of the various electromagnetic waves. See you then.
Please, if you are watching, don't forget to click the subscribe link on our channel. It is completely free, and lets you know when we upload new videos. Plus it's your little way of promoting our channel. Thank you.